Welcome one and all to the August 2019 session of the mainstream of Data Science Sydney. And thank you all for helping Data Science Sydney continue to be such a success. Give yourselves all a big hand. And a big hand for CBA, which has continued for years to be such a wonderful supporter of Data Science Sydney. I should add one more thing, that we're, as always, very fortunate to have this event recorded and posted to the Data Science Sydney YouTube channel. So who here is a member of the Data Science Sydney YouTube channel? Wow, there's actually some hands. I suggest you join it. Every single talk we do, with possible exceptions when people don't want to be recorded, it does happen, but I'd say 99% of our presentations are recorded, and this is all thanks almost entirely, there have been a few exceptions, but it's been thanks almost entirely to the efforts of one man, Greg Pearl, currently representing the Onset group. Greg is unfortunately not here today, he's not well, but he usually will make the very first announcement, which we conduct after the presentations have concluded, and Greg is a recruiter. So those of you looking to start a career or improve your career in data science, Greg is a terrific person to talk to, and you'll see him in person next month, I'm quite sure. Also should mention our other main sponsor, which is Alpha Zeta. And for those of you who don't know what Alpha Zeta is a global analytics consultancy which has recently hit 700 consultants in 45 countries. But the biggest country for Alpha Zeta is actually Australia, with 140 consultants. And here's the big difference. All Alpha Zeta consultants are independent. And here's the best part. The independent consultants get to take home 80% of what's earned from the client. So that's a really big take, and it's an opportunity for the kind of brilliant, idiosyncratic, unicorn data scientists that I know many of you are, who really don't have a place in a lot of in-house functions, be it a regular bricks and mortar or even a consultancy. It's a place for those people to shine on their own terms, working only with people they like, working only for places they want to work for, and being rewarded for it spectacularly. So if anybody is interested in a portfolio career, anybody who's already a freelancer or thinking of becoming a freelancer, and I'm talking about a serious freelancer, not you're between jobs and this is something to think about, getting into Alpha Zeta is not something that happens in 2 days. You need to be vetted. And we're looking for fairly capable, fairly experienced people. So if you're a beginner, probably good to go and get some experience first. But if anybody meets the criterion, makes the grade, come and talk to me. Come and talk to me after the presentation or during the break. I should also point out that not only is Alpha Zeta a consulting firm, Alpha Zeta is also a global analytics training company. And I'd love to tell you about all of our training offerings in data science, analytics, data governance, data ethics, and unusual things like quantum computing and even blockchain. So anybody who's interested in Alpha Zeta consulting or Alpha Zeta training, come and talk to me. So that's our sponsors and the people who've helped us. So on with the show. And our first presenter is actually an Alpha Zeta consultant.
Yeah.
ABNER has been working with Alpha Zeta for a while, and when he's not working with Alpha Zeta, he's absolutely acing Kaggle. In fact, I really don't need to tell you anything about his profile, I just need to tell you that he's ranked 676 in Kaggle, and this is out of over 113,000. He has actually won silver medals and bronze medals, and he's also developed his own outlier detection technique, which I want to ask him about because I'm really interested in outlier detection techniques. Anyway, there's a whole lot of other stuff about where he's worked, lots of interesting places and what he's done, but just the fact that he's reached that grade in Kaggle is enough reason for us to pay attention to him. Over to you, ABNER.
Oh. Can you hear me? Yeah. Oh, thanks, Eugene's introductions. Okay, my today's topic is about data science role in deep learning research and the Kaggle competitions. And for me, deep learning actually is a lifestyle. So let's start. My talk actually only in two parts. One is about my experience in two study groups, and I will talk about three competitions, Kaggle competitions. Okay, first, this is my background. My background is mathematics and master of business. And I used working in Nokia at 3G, 4G network planning. And then you can see that how we plan different mobile stations in different buildings. And then I moved to China Mobile at 3, 4G network optimizations. So you can see the left, there are some how we optimize the networks. But when I came to Australia, I think there's no strong need for mobile network planning or optimizations. So I think how to start again and maybe start a new degree. But I find something better in Australia. There was great community of data science and machine learning. So I joined two study groups. One is Harvard CS 109 data science course, and I find most material actually I have learned in my universities. So I focus on the let's study groups. We meet each week, and we possibly spend 10 hours a week on the study and on homeworks and on the projects. So for the study group, I most focus on my projects. So I use the machine learning techniques to analyze some finance data, to analyze behavioral finance, and then as the project, I submit to the Australian Finance and Banking Conference. And 7 months later, I joined another meetup group, study groups about fast AI. So at that study group, I also learn some new techniques and then do some projects. And as a result project, I find some outlier detections on image data set and then submit to the European conference and the machine learning. And after that, I joined data science Kaggle meetup. So you see that that's our first meeting in the on-site companies. So that's our first Kaggle competitions, also my first Kaggle competitions. So at that day when we form a team, such as Yuri and Java and Geoff. So at that time, we all were very excited because we find some teammates to play and then compete together. So this is a traditional way about how we see the industry and the academia and the competitions. For the academia, people are more focused on the novelties. And in competitions, people are more focused on accuracy or the score in the leaderboard. And the industry is more focused on interpretabilities and the scalabilities. But also the Kaggle competitions also change. So you still can learn a lot in Kaggle competitions about the interpretabilities. So I will explain detail about in this process. It's called cross-industry process data mining. So this is a norm. I think it's also useful for machine learning or deep learning. It just starts from the business understanding and then understand what's your data and prepare your data. And after that, you will do some modeling and evaluations. And then if the result is good, and then possibly will deploy in the industrial environment. So for the academia, possibly more focus on the modeling. So they always work on some public data set, such as MNIST, CV10, or Imagenet. And what you need to do, you will find some techniques can improve info accuracies, such as you need to understand what's the back propagations, what's the convolutional, how convolutional works, what's their mathematics background or biological background. And for those people who are not familiar with MNIST dataset, there was a great visualization about it. Actually, MNIST dataset is just handwriting. So just like 32 pixels, 32 and 32 pixels images. This is a 3 layers neural networks. So the learning algorithm is back propagation. So the blue one is their labels changes, and the front one is the images. And this is 2 layers convolutional network. In the middle is the future map. This visualization is done by cyber controller. Yeah, just finished. Okay, in that study group, I do a lot of experiment on this data set called MNIST data set. So and then at some stage I just have some idea to how to list the project's paper about how to do a targeting point attack on deep neural networks by brute force. And I think at the beginning, first I sent it to the Eugene, and he said maybe I should simplify as possible as I could. And then maybe I should start from another part called data clean. So how you clean data in MNIST. Actually, MNIST data set, I think there are maybe thousands of paper or data scientists works on MNIST data first. So at the beginning, I just do some data clean on the MNIST data set. I just use a method called majority vote. And then I find that there are actually many mislabeled dataset instant in the MNIST dataset. So after correct those mislabeled instance, actually the same accuracy, the same models, the accuracy will improve a lot, a little, not a lot, because I just collect 4 mislabeled instances. And then it can improve the accuracy. And I think it's also important, it can make the accuracy more accurate. So in the right, that's the state of the art, the accuracy on the MNIST data set. And then you can see the error is quite low, just maybe in 10,000 test data set, only 21 was mispredictions. So the rate actually is very low. So you can see that if you just have 1 or 2, and then you will become the new state of the art on the MNIST data set. And then this is from the highest one. So this is the 41 images that it was wrong classified. And you can see actually there are many handwritings. Actually, it's very difficult to say what's the true labels is. And then I think also, so they say that, okay, because our accuracy is actually, our models actually are very accurate. So those data set, I think is just some randoms by the bad handwritings. But I also find that there are some instances in the test data set. So you can see this is clearly is a 9, but actually it's all labeled as 4. And then all those models or the state of the art all predict it as 4. Because if it predicts it as a 9, and then there will be more error in their predictions on the test data set. At that point, I think that maybe there's no strong link between the instance and the labels. So that's why I come to the idea about the brute force. I just give different labels on the instance of the test data set, and then put it on the training data set, train with a ResNet, and then say whether it will be predict as the original label or the points label. And I think I just do on 1,000 instance, and successfully find 4 instances that you can make a pointed labels, such as this one, such as this 9. I can point it, make the ResNet think it is 4. And then I also want where those noise come from. So actually the MNIST dataset was selected from a dataset called NIST, actually just more handwritings. So you can see actually there are a lot of handwritings below part actually was cut wrong. And then I find that the orange papers that actually those handwritings is quite good, but just because it is close to the bottom line. So when they get those labels, they just cut those below part. And here is the example. You just say if it's a 3 and it is below close to the bottom line, and then you have cut, it looks like a 2. And then there's true label is 3. And for the NIST dataset, there are some people to audit, check it, and then change it to 2. But if you cut more, actually it becomes 3. So I think for the deep learning, actually for the labels, there's not that accurate. The labels always will have some noise in it. And then this is another famous data set called CIFAR-10. So actually CIFAR-10 is just get from the internet and then try to put like 8 million images and then selected to 60,000 images. And then you can see there were also a lot of mislabeled data set in the training data set and the test data set. Okay, this is my part on the study group, and then let's move on to the competitions. For the competitions, actually we will more focus on the data understanding and the data preparations. And most time you will do it, actually it's some kind of fine-tuning. You just need to fine-tune the image size, the learning rate, or other hyperparameters. And this is our my first Kaggle competitions. So we need to predict customer revenues. So this is supported by the Google use their G-Store. They provide all kinds of online data to us. And then they want us to predict who will come back and how much they will spend. So in these competitions, we as a team, we meet maybe 4 times, and we have 2 video calls, video meetings. So we work on from the how to set future engineers, and then to the future selections, and then to the hyperparameters turning. But as normal real-life objects, there's some change in the competitions. When it almost closed end date, some people find that the test data set was leaked in the net, so many people can just get those leaked data set and just say can have a higher score. So the Google changed their rules and then say that, okay, since it's very close, so we just say that we don't have that time to give you more data. We just based on the history data, and I want you to predict the revenues for next 2 months. And then you know that for cutting edge models, normally they need cutting edge data. It means that we need those how many people visit and how long they stay for these 2 months. But then the rules change, and then actually most data is useless. It's just the history data. So at this point, I will just change a mind and then do some maybe use some common sense baselines, and then just use some to analyze those manipulated bias. And this how many you can see that even in maybe 900,000 visitors on the old test, and we can only find maybe 12 or 10 people. We can have a higher possibilities that those visitors will come back in next 2 months. So actually, it's impossible to predict how much they will buy because you don't have the data when they visit and how long they visit. So as a result, we based on our common sense, we submit an all 0 because most people won't buy anything in next 2 months. So this is our score. So actually, you can say very close to the top 3 one. And based on the discussions or forums, those top 1 just write their write up, and then based on, and then you can see that actually they're not sure why their models can get a little bit higher. Maybe just like some random event. Some people will get hire someone will get not. So it's just like survival phenomena. So the second challenge I want to share is that the challenge that I'm currently doing, just to based on the images to predict which patient or which patient will have diabetic blindness. Just you see the images of retina. The interesting part for this competition is that at the same time, the people in the Google write a paper about 3 pitfalls to avoid in machine learning. Is that sprint data inappropriately, and the second one is hidden variables, and the third one is mistaking the objective. The interesting one is that you will meet those 3 pitfalls in this competition. At the first one, it did not separate their private dataset and the public dataset appropriately, because in the training dataset there were around 3 images. Most are healthy people, and for their public dataset, actually there are around 1,900 images. Most are unhealthy, and the image size is very different. So when we have a higher cross validations, actually our leaderboard score is decreased. So there's a very large distance between the training dataset and the test dataset. I think that's maybe the main point for this competitions is how to build your own strong CV. And this is example. If your training dataset and the test dataset or private dataset is different, the best model actually will performance worse. So this is another competition called Microsoft Malware Shake-up. So you can see that is the top one is training dataset. The bottom one is a test dataset. And then finally, this is the private test dataset. So you can see there's a huge outliers below the normal distributions of the public dataset. So you can see that if we build a strong, good models on this dataset, it works on training and it works on public dataset, but it will perform worse on the private dataset. And the second one, the hidden variables. So this is the images that are in the training data set. So you can see that someone has a great black space behind it, and someone just no very little black space. And when you ask your models to make a predictions, and there are some visual tools, and you can see that the top one, actually the models between why they are between this is labeled 0. Actually, because it's based on the weight, you can see it. Most weights are on the black space. So actually, those models based on those black space and learn and then say, okay, this is label 1, label 0. So actually, this is something that you need to. You don't want your models to learn from those things, because you want to know, want those models to know actually how the details in the retina images, and that's what you models want to know. And then I think before I continue, I want to ask you a question. If you think yourself are image classified, what do you think these images would like to be? Yeah, yeah. Most people think a cat, but an image models, no matter what is a red net or efficient net, if it trained with Imagenet, and then it will think it is an elephant. Because actually those models, actually we don't know what they learned. So actually they learned more on textures rather than the shapes. So you can see even humans can say it is a cat, but the models will think it is an elephant. So how to make sure your models are trained to avoid such hidden variables? There are some techniques that just you can say just do some image transfers to get out all the textures, and then you want your models just learn the shape of it. And then in these competitions, actually you need to cut all the black space. So no matter whether it's label 0 or label 5. And then you will need to do some visualizations. For example, this one, you can see that why your classifier think it is a label 2, because you can see that some blue part is there's some black spot in the retinas. Actually, this is how the doctors say whether this patient have what kind of risk they will have for the diabetic brightness. And then for the third one is mistaking the objective. I think for the technical people, we are more fixed on the obvious objects in the label, in the leaderboard. We just want to make a highest score as I can or as we can. But actually, in deep learning, actually there's something not like just like labels, not that clear like live and dead indicate. And you can see many labels in label 3 and 4. Even the doctors, they can themselves, I'm not sure which patient belongs to which levels. So maybe we should change the objective to say should this patient to need to see a doctor, rather than to decide whether it's level 3 or level 4, because the doctors themselves are not sure it is level 3 or level 4. So when we change to the just whether this patient need to see doctor and don't need to see doctor, actually we can already achieve very high precisions and very high recall on if we label one as those patients need to see the doctor. And I think it's very important. This is another competition to detect a pneumonia in the chest. And then say if your data set have a higher noise. So you can see some people may label opposites on different styles. And then I think not only the models cannot perform well, and then you can see that even the highest top Kaggles, they can also just maybe 0.2 in intersections over union. But when change a mind, let's see how can we, if we switch to classify problems, and then actually we can get 100% accuracy on classified problems. And based on those data, actually we are a little bit higher than the ChatNet. And the third one challenge is on about NLP. So I think this is the last Kaggle meetup I joined the net competitions, just in the net meetup. So it detects whether text is toxic or something, most is toxic or bias. So at the beginning, we have 4 people, but not many people finished the competitions. So at the end, just me to finish it. And then we can see that at the list competitions, at the beginning, I use ASTM. It have a good score, but it needs you to do a lot of data clean, such as missed spare words connections. And then at some stage, I still use a model called the BIRD that I think the most advanced transform on NLP. And then I get a much better higher score. And then if you use this models, actually you don't need to do such as data clean or misspare connections. And then I think even when the competition finished, and then you can learn from the top cargoes, and then you can see that those, and then you can say what's the distance gap between our solutions and our scores with them. Actually, it's just maybe less than 1%. And then you can say how what models actually they use. They use 2 XLNet, 2 BIRD large, and then use GDB2. And then basically you can say that, okay, our models basically is similar. So next time maybe we should use large models on those NLP classification problems. Okay. Let's for technique summary about that is that when you do deep learning, possibly you need to develop models based on your data, what data you have, and then always have come back what's the right questions for the data set or for the business understanding, and then clean the data no matter whether it's an instance or label. It will help you to improve your accuracy and make your accuracy more accurate, and then separate the data appropriately. So I think this one maybe everybody are familiar with it, but I find a new images that maybe we can switch our data and then deep learning skills. For the questions part, I want to ask you how many people have interest to play Kaggle competitions? Yeah, good. How many people think you can finish 1 or 2 competitions? Oh, come on. Yeah, maybe we can start this Kaggle competition meetup again. Okay, that's my presentations. Any question?
Yeah, how did you work out the aggregation of what should the patient see a doctor? Did you go through type 1, type 2 errors, or did you select an aggregation of features?
I think because currently they have 5 levels. 0 is healthy. From 1 to 4 it's unhealthy with some kind of risk. It just classified as 0 and non-zero. Yeah.
In the first Kaggle competition, when you had some mislabeling, how did you identify that they were mislabeling?
No. For the first competition, there are no mislabeled because the secondary. The
numeric identification.
Bears and lions.
Yeah, this is the second diabetic blindness classifier.
But because there's so much data, how did you find which were mislabeled? You just do some majority vote, and then you just use different models to do some cross validations, and then they will report some. You will have some new labels trained from different models, and then someone is different from his original label. Yeah. If you could
do that with the outliers? You could do an outlier pass and then delete the outliers because it's numbers. It's how many numbers should be right.
Yeah. It's quite difficult for training or for the doctors to see it. So just, but for the second one, maybe just, I think it's difficult for around 10 images. It's quite difficult to classify. So you just take this out of training data set. If you're not sure, because I'm not a doctor, so I'm also cannot sure whether it's, but I just take this 10 images out of the training data set. Yeah. Yeah.
All right, can you all please join me in thanking ABNER?
Thank you.
Hi, I'm Greg Pearl from the Onset group. I head up the data science and analytic area there. I hope you enjoyed tonight's presentation. Always fantastic information that we get from that. The Onset group are the premium technical recruiters across obviously data science, machine learning, NLP, artificial intelligence. I'm here to help organisations build their analytics team and their analytics function with superior talent. There's lots of people out there, really good individuals across a range of different sectors that could be beneficial. And obviously I'm also here for the data science community to assist with understanding the market, understanding what jobs are out there, how to get into data science. So please feel free to reach out. So again, it's Greg Pearl at the Onset Group, and I look forward to seeing you at the next meetup.